Okay, that's crazy. Okay. Okay, so just go over the schedule first, and then we have two presentations, and then we're going to start chapter 8. Um, so just look at the schedule for a second. By the way, there's one person I didn't give a grade for Tuesday's presentation. So if I didn't give you, if I didn't give anybody a grade, and I should have, just let me know because I couldn't figure out who it was that I didn't give a grade to because I only gave 4 people grades. Um, okay, so I mean, I could figure it out, I guess, if I watched the video, but I'd rather make it easy for me. Oh, schedule. So we want to look at the schedule. Um, okay, schedule. Uh, Here we are. Um, okay, so it looks like today is the 4th. Oh, whoa. So we only have one more class before the review. Wow. Okay. So the last day for presentation is going to be Tuesday. Okay. Okay, we're right. So the last day for presentations. Uh, okay, so now we have a presentation. So let's go there to, okay, so I'm not sure who's, you uploaded your presentation? Okay, so I don't know who goes first. You just, doesn't make a difference. Okay. Oh, we figured out how to make this work. Echo. Uh, what do we do? Oh, touched the, no, nope, wrong one. Touch the uh, audio controls, that's it. And turn on the microphone. Oh, echo. Echo. We figured out how to get it. You don't have to use the microphone. Just
Yeah,
some people
okay.
have low voices.
Okay, so hello everyone. The topic of my presentation today is what is more important, speed, security, or safety? So every tech company works with these three, but balancing them isn't always easy. So I'm going to explain what each one means and why they matters, and in the end, which one I think is the most important. Why this question matters. So, technology is everywhere. Our phone, hospitals, transportation, banking, and the app we use every day. As tech becomes more advanced and faster, it also becomes more vulnerable. Cyber attacks are increasing. Users expect everything to load instantly, and at the same time, we rely on a system that must be safe. So, deciding what prioritize isn't simple. It affects millions of people. So, what is speed? When we say speed, we mean how fast the system responds. For example, how quickly a website loads, how fast an app processes a command, or how smoothly a device runs. Speed makes everything feel better and more efficient. But sometimes trying to make things faster means skipping steps like extra testing and security checks. What is security? Security is about protecting data and system from threats. Things like encryption, secure logins, and preventing hacks. If security fails, people's personal information, money, privacy can be all at risk. So a single security breach can destroy trust in a company. So the only downside is that strong security can slow things down a little bit. And what is safety? Safety focuses on preventing harm. That can be physical harm, like with robots, medical devices, or self-driven cars, or digital harms like system failure or exposing harmful content. Safety usually requires strict testing, which takes time, but it's essential. And if technology isn't safe, nothing else really matters. So real world examples, different industries place these priorities in different orders. So in healthcare, safety always come first. The technology should never harm a patient. Security comes next. So speed is the least important. And banking, security is the top priority because protecting money and identity is crucial. And in social media, speed usually matters the most. User want fast loading and instant updates, but that sometimes leads to safety and security problem. This example shows that context changes everything. So balancing speed, security, and safety. In the real world, you can't maximize speed, security, and safety all at once. So improving one usually affect the others. For example, if you make something super fast, you might weaken security or skip safety test. Strong security can slow down performance. Safety testing often delays development. So engineers have to choose what matters the most for each situation. Which is the most important? So overall, I believe safety should be the highest priority. Unsafe technology can cause real harms in physical world. So security come next because people won't use technology that they can't trust. And speed is still important, but it only matters after the system is safe and secure. A fast system that's unsafe and insecure isn't useful. So to wrap everything up, here is the key takeaways from the presentation. Speed, security, and safety all matters, but they don't carry the same weight in every situation. But safety should always come first. No matter how fast or secure something is, it must not put people at risk. And sometimes security should be our second priority. Security builds on trust. So user needs to know their data and privacy are protected in order to feel confident using the technology. And finally, speed. Speed info improves the user experience, but only after safety and security. So a fast system is great, but if it's unsafe and untrustworthy, it doesn't matter. So overall, the challenge in tech is balancing these three priorities in a way that makes sense for the system and for the people that are using it. Thank you.
So what is the main trade-off between speed and security? Right.
So if you want to increase security, then you have to compromise this speed because when there's you cannot increase do the both at the same time. You cannot increase speed and security at the same time.
Right. That's because the encryption takes time.
Yeah.
Right, slow it down. Okay, thank you. Okay. Okay.
Good night, everyone. I will be talking about a really important idea in software development. Whenever we touch code, we should always try to improve it. This doesn't mean rewriting code or doing huge refactors. It simply means leaving the code slightly better than we found it. Small changes that we make can make a really big difference. Why does this idea exist? Code isn't a one-time thing. It keeps changing as different people work on it. What starts as clean, simple code can become messy due to new features, patch bugs, or rushing deadlines. Once a code is messy in a system, it tends to stay messy. That's why this idea exists. Because if no one ever stops to clean the code, it gets harder and harder for everyone who touches it later. Introduction to the problem. A single confusing function might not seem like a big deal, but when you multiply that by 20 people touching the same code for months or years, the confusion spreads. Messy code doesn't break right away. It breaks when you're trying to add a new feature or fix a bug, and suddenly everything becomes harder than it needs to be. This is where the idea of continuous improvement comes in. It's not about perfection, but preventing the slow decline. Why does this matter? We spend more time reading code than writing it. Most of the time, our job is understanding the code someone else wrote. Unclear code can make future tasks slower, riskier, and more frustrating. Even small misunderstandings can lead to bugs. A variable named X tells you nothing, but a variable named total price gives you meaning. This small change can prevent someone from making the wrong assumption, thus saving time and reducing confusion. Why we improve code when we touch it. Code doesn't stay clean on its own. The best time to improve code is the moment you're already touching it. You're already there, you understand what it does, so even a small change can help the next person. Improving code doesn't mean rewriting everything. It can be renaming variables, cleaning up messy logic, adding comments, or removing unneeded code. What happens when we don't improve code? It can lead to duplicate logic. Files can become so messy no one wants to open them. And eventually, the team may end up spending weeks or months doing a huge refactor that could have been avoided, but with tiny improvements along the way. How does this benefit teams? It creates an environment that cares about quality, not just quick fixes. And it makes code reviews much smoother because the code is already clean and consistent. In conclusion, we improve code every time we touch it because neglecting small issues today can create big problems tomorrow.
Very good. Very good.
We have a question.
Yeah.
Are there any exceptions to this principle?
I'm not sure. It's just always good to have clean code because when you're working in a team, many people will be looking at that. And yes, you might understand a code now, a piece of code now, but if you yourself come back to it in like a few months or like a year, you might forget what you did or how you fixed the logic. So even adding comments can help yourself in the future and anyone else who reads it too.
Gotcha.
Yes.
I can think of one, that's a very good question. I can think of one case where you would not want to change it, and that's where you're about to release it. So then the danger of breaking it is greater than improvement. Yeah, right, so right before you can do a release, they don't want you to do anything to the code. Like, even sometimes they don't want you to fix a simple bug because no one feels like testing it. So, like, because I know it where I work, we're about to release something and they don't want you to do anything to it. Go like, okay, so we're gonna do chapter 8. What? I'm sorry?
I am the one who did not make.
Okay, what's your name?
Because Vista.
Oh, just send me an email, okay? Okay, I'll remember. Okay, thank you. Okay, so thank you for saving me that I was gonna have to go through the whole list of names and figure out. Okay, okay, so, Yes, let's do that. Okay, chapter 8. Okay, so chapter, I need to get my other glasses. Okay, so basically, chapter 8 is all about testing software. Okay, so we sort of like following the development, like the first chapter spoke about requirements, and then we spoke about, you know, well, not exactly, but basically we're towards the end, we're talking about testing. So that's usually like the last step. If you write code, not the last step, but I mean, it's always, I mean, first you have to write something. Well, actually, let's see. So, okay, as we begin, I just want to explain what is regression testing. Okay, I always used to hear that word and I never knew what it was. It sounds like something really complicated. So regression testing just means that to regress is to go backwards. Okay. So like progress is to go forward and regress is to go backwards. Hey, I just thought of that. Anyhow, the uh so regression testing means that we want to make sure that we're not going backwards. So how does code go backwards? Well, it goes backwards if something that used to work yesterday, or I'm sorry, something that we fixed yesterday broke again. So regression testing means that whenever we fix something, we write a test for that bug that we fixed. So even though we could see we fixed it for today, but often when there's certain places in code where things break, usually something complicated is going on. So so usually if it broke once before, they tend to break again at that very place. So we always want to make sure that once we fix something, it doesn't come back, right, later on. That's regression testing. Now this, I actually wanted to show you. It's easier to show you a little bit from this video. This is from Bob Martin, and he actually shows how to do what he calls red light, green light, and refactor, which is, so again, if you remember, we had something called TDD in chapter 3, which stands for test-driven development. So I have to write it out because I always keep forgetting what it stands for. But basically it means to write a unit test before you write the code, right? Does that make sense? So the question is, how do you write a unit test if you don't have any code? So I just want to show you a little bit this is the guy who invented this, or he's the major proponent of this idea, Uncle Bob. So let's see if I'll just show. Wait a second. Where?
Because now I have an.
I'll just make it a little louder.
That is a first in, last out gangster. First thing you push in is the last thing that come out. It's gonna be a stack of nothing but integers. I'm not gonna try and put two errors in this thing. Nothing like that. I'm not going to use any kind of data structure other than an array. So we will work through the process of writing a stack.
Okay, so
By writing the first test. Now here's the problem. What's the test? I don't have any code. What am I supposed to test?
is everybody here?
And so here's the answer. This is always the. You already know the code you want to write. If you weren't doing test-driven development, you know exactly what you'd write. You'd write public class stack. Okay, so you just have to write a test that's going to force you to write the code you already know you want to write. This is always the rule. You write the test that forces you to write the code you already know you want to write. I already know I want to write public class stack, so what test do I have to write in order to force myself to write public class stack? create the stack, yes. So, okay, fine, I'll change the name of this to, create stack. That will not be the name of this test in the end. It's a reasonable name for the moment. Okay, I want to create a stack. Yeah, okay, what should I call this stack? My stack, I'll call it my stack. Stack equals new my stack. Oh, heavens, look at all the red. That red, that means it doesn't compile. I violated political laws. It gotta stop. Let's see if I can create the stack. Okay, I'll have the IDE create the stack for me. Create class stack. Yeah, it's stack. There it is. Oh, good. Oh, it all compiles. And I'll bet it even runs. I'm a programmer. I got that to work. Now I can refactor. I wrote a little test. I got it to pass. I can refactor this. There's really only one thing.
Yeah, okay, so he has,
That.
okay, so,
Nice stack.
okay, he has three different steps called the red light, green light, and then what's the word to refactor. So the idea is, so first you write the test that's red, it doesn't work. Then you do the green, which is that the test works. Like over here, he's creating that class. And then the refactor is to just fix up the code to make it look nice before you continue. Which feeds directly into what you were saying, right, about keeping code clean. So he does it every iteration. Okay,
There's another class in the Java library called stack. I called this stack and relied with it until I had established it in a package named stack and then everything. Does this still pass? Oh, yes, it does. Good. Okay. Now, notice that I'm not asserting anything. That's a bit puzzling. What should I assert about a brand new stack? It's empty. Yeah, okay, fine. So let's assert true that stack is empty. No, it happens, it doesn't compile. Let's see, assert true doesn't compile. Why? Well, because you have to call that on the assert class.
oh, he's a different
Oh,
library.
that's not okay. Assert class from org J unit, good, okay. And oh, happens I don't have is empty function. All right, so I guess I'll have to create is empty. All right, good. Let's see, it should return false. That'll make it fail. That's a good thing. Let's see if it fails. Yes, it fails. Good. Now I need to make it pass, and I can do that by returning true. Programmer.
He's funny.
Now I want to refactor a little bit. Now, by the way, people don't like what I just did. Lots of people look at that and go, that's stupid. Why did you return it true there? That's not the real code that goes there. My answer is, well, yeah, that's true, but I've just tested my test. I've seen my test both pass and fail. It took me no time at all. Why wouldn't I do it? So, of course I'm going to do that. A little bit of refactoring, I can get rid of that assert dot by doing a static import, I think. That should still work.
Okay, so the basic idea is you see that he's writing it, every single method he writes a test before that fails, and then he makes it pass. And then he continues on and on. It's pretty cool if you watch, if you're in, it's in this document. So when I post it, you'll see it, you could get a link to it. It actually followed through. It's pretty cool the way he, because he keeps on going, like he keeps adding little things, one thing at a time. And before you know it, he already has like this really nice tested class that works really well. So I recommend if you have time to go through the whole thing. But that's his idea of how you should do test first development. Now, to be honest with you, I don't know anybody who works like that, but it'd be cool if you could train yourself to do it. Yeah. Okay. So the other thing is that nowadays they have. I'm just thinking like we have like when you start writing something, you have AI throwing in a lot of code. So I don't know. I'm not sure how. Like because like AI sometimes I'm not sure because I just started using AI a little bit and it throws in like a lot of lines of code. So I don't know if that would work so well with his I have to see how he deals with AI. Anyhow, but this is an interesting idea, just to, if you want to, I encourage you to look at it. Okay. Okay. So what is the advantage of using unit tests? So wow, I came up with 10 reasons why unit test is good. 10 reasons we should have them. So number one is they can be run every time you have a check-in, right? Every time somebody checks in code, you could theoretically run every single unit test, right? You could have automated test, right? Just run through all of them. So you could have, let's say, every time somebody checks in a class, let's say they write one unit test. So over time, you give hundreds of unit tests and they can run automatically on, you check in your code and then somebody checks it, runs all the unit tests to make sure that everything is working. So that's pretty cool. So a unit test, you can just run by itself and you could have hundreds of tests. So it gives you confidence that your code is pretty stable. Okay, now this is if you remember from the project, a unit test must always return true or false, right? Because it has to run by itself. So the only way to check whether it's really to run it is to see if it either it works or it fails, right? So you can't. There's no like because like we just said, you give hundreds of them running every time you check in code. So there's no one to look over the results. You just got to return true or false, and then it has to check to see whether it should always be true, right? The search should always be should not blow up, right? Okay, 3 is that unit testing is not considered to be testing, but rather, especially the way we just saw, it's actually part of development, right? Because especially what we just saw that the way Uncle Bob, that was Uncle Bob. So the way Uncle Bob does, which is Robert Martin, the way he does unit testing is he does it before the code. Okay, so it has to be done by a developer. And the purpose of it is number one, well, there's 2 reasons, 4 and 5. One is it forces the developer to think about what they're going to do, right? Because if you write a test before you write the code, you're going to think about it more. Because when you have to write a test, you have to see, well, what do I want it to do, right? To test it. And 5 is that people are lazy, and this guarantees that if you use this method, that you'll always have a test because you didn't write any code before you wrote the test. So once you write the code, then people get lazy and they don't bother to write the test. Number 6 is we said this, then the company's gonna get a lot of free tests, right? They're run by themselves, I guess. Themselves. And also unit tests are supposed to be unit, meaning that what it means is that they're only testing like your class. They're not testing like many different things, right? So is this trying to test the new code that you wrote? You're not, let's say you wrote code that writes to a database. We're not checking to see if the database worked. Or if you wrote code that writes to a file, we're not checking to make sure that it wrote to a file, right? Because that's not what your code is doing. Your code is assuming that you could read from a file, assuming you could write to a file, right? Your code does is whatever it does. Okay. So unit tests should be very simple, right? Shouldn't, and we're gonna get into that, how you do that. Okay, unit tests give developers very quick feedback. Okay, that's nerds that they don't have to wait around for someone else to test it. Unit tests increase our confidence in code, make changes because we have so many of them. So we have more confidence, and and then they work well with a pipeline because again, they're automatic, right? Again, the pipeline, what does a pipeline mean? Pipeline means that when we check in the code, it automatically triggers a bunch of reactions that they're produced that our code that we checked in magically it becomes part of our program in a environment where people could test it. Okay, so so it's sort of like imagine you're writing code for a website, you check it in, so then the website will automatically get updated, right? Or if you make changes to the database, it will automatically do those changes so people could test it. Okay. So in this chapter, there's basically, again, this is pretty much straight from the book, except that I thought the book was pretty confusing. So I just took out the parts that I think I tried to simplify it, but pretty much is from the book. So basically there's 5 steps in testing. There's, of course, every company could have more or less, but basically, if you break it down, there's 5. Well, one way to break it down is 5 levels. Like you could always, like people always think of ways to, that you could categorize people by some people are type A and some people are type B, right? So that's one way of making defining people. So this is not necessarily it's just a way that when I read the chapter, this is what I came up with. Okay. Some people might have more stages or less. Okay, but development testing is basically the testing done by the programmer, which we just got through, is unit testing, and we did in the project. So I'm not really worried, and we just saw in the video. Component testing is really similar to development testing, except that it's already testing not the actual objects that we wrote, but the interaction between them. Okay, so component testing is like we're going more on more of a macro testing level, right? So micro would be development testing, where we're just testing our own code, and then component testing is where we're testing how well everybody's code interacts with each other, and then system testing would be we're testing the whole system. So I wrote on top is that these first 3 is we're looking for bugs, right? Our main goal is to make sure the code works correctly. Not necessarily that it does what it's supposed to do, but that it works. Okay. So, and then we have release testing where over here, it's more, the emphasis is not on is the code reliable, but over here we're switching to making sure it does what it's supposed to do. Okay. So the system so these 3 levels are just like trying to make sure everything works. And when we get to over this phase over here, we're not testing anymore we're not looking for bugs. We just want to see if it does what the functional requirements, right? And maybe the non-functional. So that would, and also is very important. It's done not by a member of the programming team because they're probably going to be biased how it should work, and they don't think how the users think. So we need someone else to test it. Okay. So like, for example, where I work, you always, whenever we check in something, we say it's fixed, we always have to have a second person test the code, right? Not the person who wrote it, right? So, which is a very good practice because the person who is a non-member is going to, use it differently than we think, right? Like you buy a toy for a kid and you think that, they should use the toy a certain way, and they think of other ways to use it, right? They'll throw it at each other or something, right? So So just because we think code should be run a certain way doesn't mean that it will be used that way, right? People could have all different ideas. And then user testing is basically when we think it's done and we give it over to the user and we say, okay, your turn. What do you think about this? Does it look like it does what you want it to do? Okay, so these are all the 5 phases of development. Okay, so so now going through development testing, um, um, so oh yes, we spoke about this about it. Now, okay, now now within testing there, but let's say development testing, there's basically 2 ways to test. There's like, I mean, there's a lot of ways to test it, but the book brings us down is that there's 2 ways, which are basically the first way is called partition testing, or it's also known as edge case, edge conditions. So also known as edge conditions. So that's where we want to make sure that in other words, like if, for example, I give an example here, like if 1 + 2 = 3, right, there's no point in making another test that, let's say 3 + 1 is 4, right? It's not gonna, it'll be a waste of time, right? Because if 1 + 2 = 3, chances are that 1 plus, I'm sorry, 1 + 2 = 3, so 1 + 3 will be 4. What will be interesting would be is if we try to crash it, right? So for example, let's say we add 2 huge numbers together and see what happens, right? Does it work as is it within the spec of how we think it should work, or or does it break or not? So like they give an example over here, like let's say we have, let's say a program expects let's say a social, let's say a number between 4 and 10, let's say, right? So it has to be at least 1,000, and I'm not sure what 10 zeros. 9 zeros is what? Uh, 9 zeros is a billion. One with 9 zeros would be a billion, right? So it's between 1,000 and a billion, I think. So we would check. So instead of checking, let's say every number between 1,000, let's say, and 2,000, right? We would check to, I don't know why they did it like that. But the idea is, like over here, so you would check the boundary conditions, meaning you write a test where you only passed in 3 digits, and that should fail, right? So, and then you pass in 4, which is on the border. So we would look at the border conditions, right? Right at the edge of where it should work and where it should fail, right? In other words, what's the maximum we accept, which is 10 digits. And so we make sure 10 work and 11 fail. And then we would do 1 just to be, we do 1 in the middle between the lower case and the higher case. So that's called partition testing, where we don't just test any input, but we look at inputs based on the minimum and maximum values that should work, right? So, which makes sense, right? Why waste your time testing, this, like, for example, with the adding method, adding 1 + 2, 1 + 3, 1 + 4, right? You should try something interesting like negative, whatever, plus, minus, whatever, -1, like 1 and -1, something more interesting than just a, 1 + 2, 1 + 3, 1 + 4, 1 + 5, right? So, okay, so that's called partition testing. Okay, is that clear? So the idea that we're looking at inputs to see, we're not, we're trying to test right at the very edge, right? Where things should fail and where it should start working. And again, where something, and the minimum and the maximum, it's usually a minimum maximum and something in the middle just for the fun of it. Right, but not too, but in the middle, in general, will always work. You know, if the minimum works and the maximum works, you really don't have to test anything in between, right? So that's partition testing. Guideline-based testing means that people who have experience know that certain things crash a method or a program, right? Like, for example, if I would give you google.com, how would you crash it, right? Like you don't have any partitions that you know about, right? So how would you try to crash it? Well, from experience, you would know that how would, like, I'm sure that like, I can't crash it because I'm sure it's been debugged, you know, but let's say you wanted to crash it, let's pretend, right? Or I don't know, yahoo.com or something maybe that's not tested so well. How would you crash it? Let's say maybe Wikipedia, how would you test it? How would you try to crush the search? Um, Anybody have any ideas?
You just like overload website with too much traffic or something.
Oh, okay. Right. So you know from experience that that could crash something, right? You have too many requests, right? Yeah.
Try to use a character that's not an English one, like some foreign language they have to cut and paste.
Oh, okay. Yeah. Okay. So unusual characters, or I was thinking trying to, I was thinking of like cut and paste like a huge article, put it in the search bar and see what happens. So, or take HTML or JavaScript and paste that in and see if it knows that it's dangerous or something, you know. Um, um, but yeah, those are all good ideas. But that's based on just intuition. So that's what they mean in the book when they call it guideline-based testing, right? That's where you know from experience that if you overload it, if you give it nothing, right? Like maybe if you search for nothing, it might crash. Um, or you give it too much, that sometimes crashes it. Um, or you overload it, right? So those are all ways that we know based on our experience that programs could crash, right? They're only designed to handle, let's say, this many characters. Let's say there's a field where you fill out first name and you put, let's say, 1,000 characters in it. Will that crash it, right? Well, if you enter a first name of 1,000 characters, will it handle that gracefully? Or will tell you, well, or will it crash, right? If it's not well written, it'll crash, right? If it's using a back end of a database, right? Does anybody know about SQL injection? Or there's also HTML injection. Do you know about that? I don't know much about it, but apparently you could, like when you do a search, you could actually like put like code and that will like expose the web page or parts of the web page. So you could um the example I think I said was you click on a link and then it goes to a real website, but when it searches for something, it's actually putting an image into the web page, and then you click on that image, then it takes you to your site. Uh, and I got it from a YouTube video, and it was actually they took, I think it was for Harvard.edu, and it took, or maybe it was online, Harvard Online, and it took them like a couple of years before they fixed it. I think they finally fixed it, but I used to use it as an example of HTML injection, SQL injection. Does anybody know what that is? What would that be? Like what? How would
Well,
you do
if you're
that?
going to you're putting in your like username or password, there's a few things you can do, but like a simple one is, in SQL, no matter what line, that you could have a statement that's across like 20 lines, you have to wait for a semicolon. So if you're like injecting your username in there or something, you could put it in a real username, then write a semicolon, and then write a SQL query that like deletes the table that you're looking at. And then by doing that, if they're not careful for it, you could delete the entire
Right.
database of usernames or passwords.
Right. Right. So basically, if the programmer is a little bit lazy and they're just taking whatever you type in and putting it straight into a query, no, they're actually, in other words, there's two ways to add data, let's say to a query. You could either just say where name equals and then whatever the user typed in, and then you pass that query to the database, which would be the scary way of doing it because they could type whatever they want. Or you could, there's a way to do it where you just set a parameter value, so then this way will not work. So then you can't mess up the query because then it's in a parameter value. I forgot, I'm not sure exactly why it's safer, but it is. You can't, and then you can't do it. So basically, that would be most websites I think have been fixed for that, but it used to be a big thing that you could, not only that, you could run a query to see, like, if you know what, you could like run a query like just to see what tables there are, and they show up on the on the website, and then you could drop the table. Yeah, it's pretty cool stuff. Though of course the user should not have that permission, right? The person using the program shouldn't have that access permission. Okay, so this is development testing. Another thing about development testing is what's known as black box versus white box, right? So what is black box in programming? Right? When you say it's a black box, what do we mean by that? It means that it's under the black box. It means that we don't have to know how it works. We just know it works, right? Like you go to your car and you push the button and it turns on. You don't have to understand anything about it. It's for you, for most people, I should say, it's a black box, meaning you have no idea how the car works, what happens when you push the button, what's involved. Just push the button and the car goes, right? White box would be, let's say, a mechanic would turn on the car, so they understand what's happening when they push the start button, right? They would know what's going on in the car. They could, and so there's advantages and disadvantages to each. Because black box means that if you don't know how something works, so then you like we just had with Google.com, if you want to break it, right? We could we could be more creative because we don't know how it works, so we could think out of the box. Right? But white box is more like if I understand how something works, so then I could zero in on the parts where I know it might break. Like, for example, let's say I'm a mechanic, I know how the start button in the car works. Maybe I'll push it 3 times real fast and see if that'll, I don't know. Don't do it on your car, you might destroy it. But for example, right? If you're trying to test the start button of a car and you're a mechanic and you know how it works with the relays and all that, so then if you push it 3 times real fast, that might test it to make sure that doesn't break the engine when you do that, right? Because it might blow it up. On the other hand, a regular driver would never probably think of that. Okay, then we already spoke about component testing, which is, and then we're moving to system testing, where the whole system so we said component is testing the different different parts of code, and we see how they interact with each other. And system testing is where we test the whole system. Okay. And then finally, we get to release testing where we have the whole system and we want to make sure, remember we said we're trying to see not that it works, but that it does it meets the requirements of the users, right? So we're pretty sure when we hand it off for release testing that it's not going to crash anymore, right? But we're not sure whether the users are going to be happy. So the release testers, they make sure that they go through the list of features that we, agreed upon, the functional, the functional requirements, and they make sure that the software does it. Okay? And then, okay, then we have user testing, which basically means the user looks at it, they install it maybe on their computers, and they do a trial run, make sure that it does what they want it to do. And then we have alpha testing and beta testing. Alpha testing just means that we give it to some clients. Like, for example, you would wonder, why would someone want a pre-release version of our code, right? What's the point, right? But some people, like, let's say, for example, Microsoft Word, let's say there are people who have let's say an AI which works with Microsoft Word. So when Microsoft Word comes out with a new version, they want to make sure, let's say, that as soon as it comes out, their software will work with the new version. So these type of people would be perfect for alpha and beta testing, right? Because they want to be the guinea pigs, because they want to be the first people to be able to make their products interact with our product, right? So where I used to work, we didn't really have a test. My job before this, we had like a small company, so we really didn't have a lot of testers. So when the company we asked for a new feature, the way we did it was we made a feature, but we only gave it to one company, the one they'd asked for it, and we tell them, there's a new feature we wrote just for you, and you're the guinea pig. But they wanted it, so they were willing to be the guinea pigs, right? And then if if it worked for like a month without breaking too badly, so then we would give it to all our customers. So that's how we did testing. It's not the best way to do it, but basically, that would be alpha testing, right? You give it to somebody who's willing to who's willing to put up with code that's not that may not be that's pre-release. And then beta testing is where you give to more people, and then acceptance testing is where you actually give to the customers and see if they're happy. And that's basically it. Okay, that's really chapter 8. There's a lot of, different ideas there, but this is basically what I want you to remember. And then this is just straight from the book. I just copy the points they make. So, yeah, it's basically what we just said. Okay. Except they mentioned this idea of scenario testing, where you pretend that you're a real user of the system and you try to run it different scenarios. Okay, but that's pretty obvious, I think. Okay, so that would be chapter 8. Okay, so, the next thing I want to do is go into, let's see, we have two different ways of, is I wanted to, we're not giving that much time to do it, so let me go through, where did I do it? I put it somewhere. And let me just do it by date. Where is it? Oh, I had it. Definitely have. Oh, let me just see in my Word if I have. If I was looking. Here it is. Oh, I forgot to save it as. Okay, so, okay, here's some ideas about testing code. It's a little bit out of order because I was, we don't really have enough time to do I want to do a small example of writing testable code. So we'll do that next on Tuesday. So, but this is basically things that I sort of found on the internet. So these are ideas about checking for um, writing testable code. Okay, so one idea of writing testable code is that we should have access to the code. So to test it in different parts of it, because if you're testing one big thing, it's hard to narrow down where the bug is, right? So when you write code, I'll give you an example. Like if you have, let's say, let's say I have class, um, I don't know, foo, and um, and whatever, and they have, let's say, method. They have, let's say within the constructor, I do, I call method one, I call M1, and then I call M2, and then I call M3. So I call three methods. So it's really going to be hard to understand where if it, let's say there's an exception, or let's say actually let's call it um, method one. So if I call method one, right, it's hard to know, right? It's hard to test what went wrong, right? Let's say this method one returns a Boolean, right? And it fails. So it's hard to understand, since it's calling three other methods, where it's failing, right? So this would be example where we don't have seams, right? Seams means that there's breaks in the code, sort of like, when you have clothes and you have like a seam where, where like, let's say a tailor is gonna work on my sweater, they would look at the seam where over here, right? You wouldn't cut it over here because that would be in the middle, right? But you look at the seams because those are places where the parts of my sweater are attached. So the same idea with code is that you should have breaks within the code so that you could test one part at a time, right? We don't want to have to test a whole big thing and then, let's say method one, that's right. I don't have access to M1, M2, and M3, right? I want to be able to have test M1 by itself, M2 by itself, M3 by itself. Okay, so that's the idea of a seam. Okay, we want to have access to um, to different parts of the code. Okay, I'm sorry. Okay, another idea is oh, okay, actually, we're going to see this on Tuesday, but the idea is um, that um, okay, is that okay, let's go down here for a little bit. Um, I had a link and okay, maybe I'll just show you really quickly. Well, actually, I'll explain. So basically, the point like this is that, let's say I write code, which look at this over here, right? So what is the code doing? It's reading a file. It's and then it's I'm not sure what content string, and then it's looking at the contents. I'm not sure why the arrows. Oh, I see. The input file is on the on the right. I don't know why they did that. I would have put it on the left. And then the output file is uh I okay. I'm not sure what okay, but the idea is that let's say I have a program that reads a file called input.txt, right? And then it counts the number of words that are repeated, right? Okay. And then it writes it out to a file. So it reads a file and it writes to a file, right? What's wrong with that program? Or how would, not what's wrong, but why would that be hard to test? In other words, my code is basically counting the words inside the file, right? I want to see how many words are repeated within that file. And but in order to do that, I have to read a file and write to a file, right? I have to write the result to a file and I have to read it. So what could go wrong with that? Well, that means that in order to run my test, right, let's say I check it in my code and my code is automatically run by the pipeline. That means that the pipeline has to have a file called input.txt lying around somewhere. And that's also assuming that this unit test has the ability to, in the libraries, to write to a file. Maybe it doesn't have a write permission on that server, right? So a lot of things could go wrong. And all I'm really trying to do is write a method that counts words, right? I don't really, the reading and writing, that's really, that's not really part of my code. I just need it in order for my code to work, right? So the idea is that we could separate, so the reading and the writing, they're called side effects. And the idea is we want to have a unit test that could just test the logic of my counting the repeated words rather than also dealing with reading and writing, right? We don't want our unit test to have to deal with reading and writing, right? So the way we do that is we write a method, we create two methods called read and write, which are which we are fake methods. So our code will still work, the unit test will still run, but but you don't need a real they're not really writing or reading, right? It's called mock, you're mocking up these methods, right? You refer to that, right? The idea is that you pretend that you pass in a library or interface there or a class that doesn't really do anything, right? But it looks like it's doing it, right? It has the same signature as the real one. So that's the idea of side effects. Okay, so okay, actually, I'm going to do an example next time. Let's just maybe I'll just finish this up. It's easier once I do the example, and you can see exactly what I mean. Okay, all these ideas. So, but I'll post this. If you have a chance, look at this video. He actually, it's a very good video. He actually uses this example of this of the input file, and he actually does it. He shows how to make code which is which is free from side effects, I'm sorry, which could be tested without side effects, right? So if you click on this link, you could see it. But we're going to do something on Tuesday, which is basically going to which will illustrate all these ideas. So okay, so I thought I saved it somewhere. Okay, so so I see you on Tuesday, and then we have the review on. I'm sorry, I see you on Tuesday, right? Review a week from tonight, right? Okay. And then maybe we'll have I'm not sure when the final is, but does anybody know when the final is?
It's the last day of finals.
Oh, really?
And it's, yeah, 8:30 on the last day of finals.
Oh, man.
22nd.
Wow. Crazy.
Or, no, it's the first day of the, it's the first
the
day.
first day?
It's 8:30, 16.
Oh, okay. So-
16th.
Okay.
Yeah.
So we'll try to have an extra review on, like we did last time on Sunday. Okay.
Professor,
Okay.
what is the final again? I'm sorry, I didn't hear him.
No, I said that I'm sorry, what was your question?
When is the final date? The date for the
Uh,
final?
You can look it up. Is it still Blackboard? Could you look it up on?
That's the bright space now.
My private stage just doesn't work because my password's like not letting me log in.
One of the students,
Pretty sure it's the 16th.
they said it's the 16th. I'll check.
Okay.
I didn't see myself.
Okay.
8:30 to 10:30, yeah, it's crazy. What? Yeah, it's here, in this room. I'll check for you for next time, okay?
Thank you, Professor.
Sure.
Have a great one.
Okay, good night.
Yeah, well, as a. Like, I didn't like. This one.
Okay, see you.